Hello everyone, I am Prathvishan. I am presenting technical seminar topic of IoT based portable grader with counting mechanism for fish seeds. In India, freshwater aquaculture accounts for nearly 55% of total fish production, with ponds and tanks being primary resources of freshwater. Considering the abundance of aquatic resources, India has been blessed with only 10% of its natural potential is currently being used for aquaculture, and hence it can be stated that our productivity is less than our potential. This is mainly due to inadequate supply of fish seeds, insufficient stock density, absence of right size and quantity of seeds, poor husbandry practices, unavailability of technology to farmers, and lack of coordination between producer and consumer. Fish seeds sold to farmers by seed vendors are not of uniform size and accurate count, as they are not graded and counting is done either manually or fish seeds are sold by weight. Hence, there is higher probability of farmers getting cheated by having paid more for less number of fish seeds, as there is no cost control due to the absence of Seed Act in aquaculture. In Karnataka, there is a deficiency in production of fish seeds, the requirements being 42 crores per annum, but the actual production is only around 20 crores per annum, which means there is 50% deficiency. There is a vast potential to produce seeds by the farmers. This issue is not specific only to Karnataka but persists in many other states of our country. Stocking and rearing of non-uniform size fishes causes higher mortality in fishes, resulting in poor yield to farmers. Then that is much less than the actual potential. The main motivation of this project is to introduce proper grading and counting mechanism to Indian farmers and vendors for their benefit, that eventually lead to growth of aquaculture industry in our country. One of the earliest known methods have been grading and counting by hand, which is the most inefficient and time consuming method known. There are more crude and manual grading tools such as plastic basin, plywood or meshed box, sorting table, grading cage, dip net, etc., none of which guarantees a good efficiency and therefore unreliable and uneconomical on large scale. There are also algorithms developed on basis of machine vision, which is difficult to implement. According to market survey, fish graders and counters are not manufactured anywhere in India. They are commercially available in foreign markets and they are very expensive for Indian farmers to invest in. These are some of the foreign products available for grading of fishes. As of now, there is no such product manufactured in India. This is the block diagram of fish seed segregation. Initially, fish seeds are kept in reservoir. By the help of flag mechanism, it will pass into fish entry hopper through grading plane. From fish entry hopper, fish seeds will fall onto grading mechanism, that is V-grooves. With the help of conveyors and water bars, the fish will fall onto outlet pipes based on their sizes. From each pipe, fish will pass through counters and at the end, it will get collected in collecting trays. This is the 3D model of the grader. As you can see, the major parts are frame, reservoir, entry hopper, V-grooves, conveyor, collecting chamber and counter. Total length of the model comes around 2 meters, with V-grooves occupying 1.3 meters. The width of the V-grooves varies from 3 mm to 16 mm, with varying rate of 0.5 degree per mm along its length, which allows the fish to fall through it while segregation. In this grader, the fishes are graded based on their thickness. So here below 3.75 mm thickness is collected in one pipe and they are called fries. Above 3.75 to below 6.25 mm thickness, they are called fingerlings and they get collected in another chamber. And above 6.25 mm thickness get collected in third chamber and they are called advanced fingerlings. Main features of this grader are fish seed grading, counting of graded fishes, mobile grader counting system, independent grader and counter, and also provisions for control over various parameters such as conveyor speed, fish flow rate control using stepper mechanism. This is manufactured grader for fish seeds. This is the front and side view of the grader. Here you can see the 3D model of counter, which contain laser detector and a mesh to drain water so that it won't interrupt the counting of fish seeds. This is how actual assembly of counter looks. These are the sensors to monitor the speed of conveyor, which is powered by variable frequency drive motor whose speed can be varied manually. This image shows the flap valve assembly, which is actuated by stepper motor to control the flow of seed along water from reservoir. This is the electrical control board, which helps in controlling the process manually. The whole process can be monitored and controlled through online. This block diagram shows how IoT can be used for the same. Through this, a proper rules and regulation can be set while transaction between vendor and farmer happens. Blink app is used for the control and monitoring the process. These are the controls and monitors available for this fish grader. Video showing how grading happens in the grader.
So we have an initial count of around 12. So now I am inserting a fish into the counter. You can see that the counter is incremented by 13 and fish is coming out. So see, so same way I am in.
Manual speed control of conveyor is employed to push the fishes forward in the V grooves in case they are overcrowded or stuck at any point. The speed of the conveyor affects the rate of grading of fish seeds. These are the results obtained through Blink app, which has on-off controls and email notifications. Also, we can use Blink app to monitor the fish count, conveyor speed, temperature, and flow rate. Overall cost of this completed product came up to 1.55 lakhs. In mass production, the cost can be reduced approximately to 1 lakh. These are the references that we referred for our project.